What's up guys? You already got to know orbitals in a previous video. In this video, we are gonna explain the relationship between orbitals and atomic bonds and what sigma and pi bonds are. Okay, orbitals are related to the bond between two atoms. An atomic bond is created where two orbitals overlap. In this picture, you can see the overlap of two spherical orbitals and the overlap of two p orbitals. One electron comes from each orbital. Together, they form a bond between the atoms. This bond is called a covalent bond. This is also sometimes referred to as an atomic bond. The two terms are interchangeable. Take two hydrogen atoms for example. The hydrogen atoms both have the following electron configuration. There is one electron each in the 1s orbital. The two spherical orbitals overlap and form a hydrogen molecule. The hydrogen molecules each share the two electrons. Sharing is caring. That is how a covalent bond is formed. Another thing to remember, electrons only create bonds with other atoms if they are alone in their orbital. If there are already two electrons in an orbital, it cannot take another electron from another atom. If you look at the electron configuration of hydrogen, you can see that there is only one atom each within the s orbitals. Together, they create the bond. Let's examine hydrogen fluoride for another example. For this, we will look at the electron configuration of fluoride and hydrogen. You can see that fluoride has the two s orbitals and two p orbitals filled with two electrons. A 2p orbital is only equipped with one electron. According to Bohr's model, fluoride only has 7 valence electrons, meaning 7 in the outer shell. But only one valence electron forms a bond with another atom. This is seen in hydrogen fluoride. In it, the dumbbell-shaped p orbital and the spherical s orbital overlap. The two single electrons pair up and form a bond. It is also important that the direction of the spin of the electrons is opposite. You can imagine a couple, for example. Depending on the direction of the spin, you can imagine men and women. The electrons that already have a partner don't create a bond with an electron from another atom. They already have a crush and are taken. Only the lonely and single electrons are looking for a partner to form a new bond with. They are really desperate for another electron. The orbitals with only one electron are used for the bonds, and the spin of the overlapping orbitals has to be opposite. If the spin of the two electrons is the same, one of them has to turn around for the bond. Okay, you need to remember that there are two forms of covalent bonds: sigma bonds and pi bonds. Let's first take a closer look at sigma bonds. In sigma bonds, the orbitals overlap rotationally symmetric around the bond axis. What in the world is rotational symmetric? You have a bond between an s orbital and a p orbital, just like with hydrogen fluoride. Draw a line between the atomic nuclei of the axes. If the orbitals overlap on this line, the bond is rotationally symmetric. This also works if two s orbitals overlap, just like with the hydrogen molecule. The overlap of two p orbitals can also be rotationally symmetric, but not necessarily. A sigma bond is created in the fluorine molecule consisting of 2 times fluorine. You can see the bond is on the axis again. Alright, that's it for sigma bonds. Now let's look at the other form of covalent bonds, pi bonds. This is where the orbitals don't overlap in rotational symmetry. It is created from the overlap of two p orbitals, just like here. The overlap is above and below the connecting axis. If you connect the nuclei, the line does not hit the overlapping area. That's how to recognize a pi bond. Alright, Now quickly for the differences between sigma and pi bonds. Sigma bonds are stronger than pi bonds. Sigma bonds are more stable and less reactive. Pi bonds are comparably weaker and therefore more reactive. They can be attacked more easily by particles with a positive charge. It's also important that sigma bonds are always in the same location. You can tell where exactly they are. Pi bonds are the opposite. To show this, let's look at another pi bond. If you have two overlapping p orbitals, you can't definitively say if the bond is up here or down here. The bond is delocalized. Last but not least, it's good to know that with multiple bonds, the first bond is always a sigma bond and the rest are pi bonds. With double bonds, you always have a sigma bond and a pi bond. With triple bonds, there is a sigma bond and two pi bonds. On top of that, sigma bonds are freely rotatable because of their rotational symmetry. Pi bonds are not rotatable. If you have a plastic model of a molecule, you can't rotate the double bonds, only the single ones, meaning the sigma bonds. Okay, so far so good. Remember that covalent bonds are created because the orbitals of two atoms overlap. You should also know what in the world rotation symmetry is and the differences between sigma and pi bonds. See ya!